As I'm sure you've realized, water is an essential chemical component of life. The cells of all living things are primarily filled with water. It is a key component in photosynthesis and other organic processes, and it covers most of Earth's crust. It is on Earth's surface in various forms, in its atmosphere, beneath the surface, and in all of Earth's living things. Water is constantly moving through all of these living things and places. But how? The water cycle is the continuous movement of water from the surface of the Earth to the atmosphere and back. In reality, there are countless paths a particular water molecule could follow through the water cycle. It could drift around the world in the atmosphere, be stuck in a glacier for millennia, or spend time in an animal or plant. But the general cycle works as follows. Water on Earth's surface gains energy from the environment and changes state from a liquid to a gas, evaporating and moving up into the atmosphere. When it cools, it condenses back into a liquid and sticks to whatever solid matter is available. This could be a window, blade of grass, or dust in the air. If it condenses on dust in the air, clouds form. When the cloud reaches a saturation point, meaning that they have more water than they have surface area to hold, the mixture of water and dust begins to separate, and the water begins to precipitate or fall in the form of rain, snow, or sleet, or hail depending on the temperature. Once on the ground, the water either percolates and infiltrates the ground, seeping into the soil and becoming part of the groundwater, or it runs off, flowing into local streams, rivers, and working its way towards the ocean. Any time that a water molecule is on the surface of the Earth and exposed to additional energy, though, it has the potential to vaporize again, evaporating and re-entering the atmosphere. All of the water on Earth is linked, whether directly by rivers and streams or indirectly by the water cycle, and constantly flows from one body to the next. We can group bodies of water such as rivers, streams, ponds, lakes, and oceans based on how they contribute to each other. The streams and rivers, both forms of runoff, that run into the same large body of water, whether it be a large river, a pond, lake, or an ocean, are called a river system. All of the smallest streams and rivers contributing water to the larger body of water, in this case being called tributaries. All of the water in a body of water does not necessarily have to precipitate directly into that body of water, though. It could fall on the surrounding land and then work its way through the ground to a tributary or the main body of water. As a result, the land surrounding the river system has to be included. All of the land that contributes water to a river system is called a watershed. Watersheds are usually highly protected areas because any pollutants that end up in the soil there eventually work their way into the water supply. Once water reaches the ocean, it continues to move in the form of tides and ocean currents. Tides are larger movements of water affecting all of the water on Earth simultaneously, but currents behave differently at different locations of the Earth and can have significant impacts on climate. Surface ocean currents flow in large circular patterns, each occupying large portions of the ocean. They are affected by several things, including the movement of the air, the Coriolis effect, the position of the continents, and temperature. Liquids and gases tend to move from warm places with lots of energy and high pressure to cooler areas with less energy and lower pressure. As a result, warm air and water from the equator tends to move towards the poles. That means moving north in the northern hemisphere and south in the southern hemisphere. Since the Earth is also rotating on its axis, fluids trying to move north or south also get pushed to the side. If you were to look at a map with the northern hemisphere at the top, everything is pushed east by the Earth's rotation. This is called the Coriolis effect. The Coriolis effect, coupled with the north-south movement of water because of temperature, causes Earth's oceans to move in large spirals. In the northern hemisphere, these two forces cause the surface currents to move in a clockwise motion, and in the southern hemisphere, they cause a counterclockwise motion. You can see the currents in the slide moving clockwise in the north and counterclockwise in the south. The red arrows indicate that the water is warm during that stage of the current, and blue arrows indicate cold water. Deep ocean currents also exist, but they depend more on temperature and the density of water, which changes with the amount of salt mixed into the water, and while they do affect ecosystems notably, they do not affect surface climates as much. You can see the currents in the slide moving clockwise in the north and counterclockwise in the south. The red arrows indicate that the water is warm during that stage of the current, and blue arrows indicate cold water. Deep ocean currents also exist, but they depend more on temperature and the density of water, which changes with the amount of salt mixed into the water, and while they do affect ecosystems notably, they do not affect surface climates as much. Since water changes temperature much slower than air does, a prevailing wind that comes from over a warm ocean will be warmer and bring that warm air to the land. As a result of the surface ocean currents, some places that are quite far north have warmer oceans than expected and have altered climates. Places like the British Isles and the Pacific Northwest have milder climates because of the ocean's warming effect. Since the air bringing this warm air comes from over the water, these prevailing winds also tend to bring a lot of moisture onto land and cause these places to be frequently cloudy and rainy. Land along cold ocean currents experience the opposite effect. Places like Southern California are drier because the cold ocean currents limit how much moisture builds up in the air. Periodically, water temperatures can change, as happens during El Niño and La Niña, which can affect the ocean currents and weather around the world, causing unusual storms in some areas and droughts in others.